Let's look at functions and the vertical line test. Let's determine whether the following equation defines y as a function of x. Now remember that in an equation of two variables, if each value of the independent variable there corresponds exactly one value of the dependent variable, then the equation defines a function. In other words, if each allowed value of x maps to exactly one value of y, then the equation defines y as a function of x. So solving our equation for y gives us 3y is equal to 2x minus 6, and then dividing both sides by 3 gives us that y is equal to 2/3 x minus 6 divided by 3, or 2. Now for each input of the independent variable x, there will be exactly one unique output y. So yes, this equation does define y as a function of x. So yes, y is a function of x. Now another way to reach this conclusion is to think of the graph. The graph of this equation, y is equal to 2/3 x minus 2, is this line here, isn't it? It has y-intercept at -2 and a slope of 2/3, which means we go up 2 and over 3. Now there's something called the vertical line test. Which gives us a way to determine whether an equation defines y as a function of x by looking at its graph. And what it says is that an equation defines a function if each vertical line in the rectangular coordinate system passes through at most one point on the graph. And so looking at our graph here, any vertical line that we pass through this graph will intersect the graph at only one point. So it represents a function. And the reason this is true, why this works, is because what is the equation of a vertical line? It is x equal to something. And so if it hits that graph at only one point, that means for that x value, there's only one output y. All right, let's look at another example. Let's determine whether this equation defines y as a function of x. Again, let's solve for y. So we have y squared is equal to 9 minus x squared. Or y is equal to plus or minus the square root of 9 minus x squared. So no, this equation does not define y as a function of x. Because for whatever allowed value of x we put in here, we have two outputs, the positive as well as the negative. And what does the graph of this look like? If we add y squared to both sides, we get x squared plus y squared is equal to 9. Isn't that just a circle centered at the origin with radius 3? So this is 3. And if we pass a vertical line through this graph, it's going to intersect it in two places, isn't it? Therefore, by the vertical line test, this equation does not define y as a function of x. And this vertical line that was just drawn here is at x equal to 2. And if we plug x equal to 2 in here, what do we get? We have y is equal to plus or minus the square root of 9 minus 2 squared, or 9 minus 4, which is 5. Which means that for x equal to 2, there's two different outputs, so it is not a function. All right, and this is how we determine whether an equation represents a function. Thank you, and we'll see you next time.